I have opened the handgrip data set for the first activity, and I have my puppet because I have a feeling I'm going to need to do a lot of pointing in this video. So first of all, the main variable that we're interested in is this average hand strength, and the average refers to the average for each participant because they were given 3 goes to do this hand grip strength, and I encourage you to read the paper to get some of the details around this. But essentially, they were interested in older people and whether or not having an age comparison, social comparison made to them, making them aware of their age, caused them to be weaker. And the two outcomes here, average hand strength and average hand time, we're just going to look at average hand strength. And in the version of the data, I'm not sure why, you might be missing the data code. So if you go into values, and I'll just pop them up there so that you can pause and write them down. They do seem to be backwards coded to me. I would have thought normally you start for 1 for the least severe and 4 for the most severe. But anyway, we'll have a look at that. And so the main experiment was around the condition that they were under, whether or not they had this age comparison made or not to make them feel old, and that's condition. So there were 2 groups, the treatment group and the control group. So if you wanted to test this outcome by condition in a simple analysis, you could just do an independent t-test like we saw last week. So what we're going to do is take a look actually at arthritis, because this has the 4 levels. Oh, now I just realised I put this in the wrong thing. Hold on. Let me copy that. Put that in arthritis. There we go. And I'll go through and delete this. I don't know what I was thinking. Remove, remove. I probably did the same thing in class actually as well. Okay. So hand strength is continuous, that does not need any values, and that severe to moderate belonged in arthritis. I was getting ahead of myself. Pop that up again if you need to pause. Okay, so we want to have a look, is there a difference in the hand grip strength for the different levels of arthritis, for which we have 4 levels? And this is an ordinal variable, and it's possible that you could measure arthritis in a more detailed way. And then it might be possible actually to do a regression between hand strength and severity of arthritis. We're just going to treat it as categories in this case and have a look at if we can do an analysis of variance. So I encourage you to read through the layered statistics page to look at the assumptions, and I'm going to jump right in at assumption number 4 with whether or not there are outliers. And hopefully by the end of this week everyone can do box plots and histograms with their eyes closed, because they have done so many. So let's go into the chart builder and we're going to have a look at outliers. So just to remind you, if I just quickly run through the assumptions, the first assumption is that our outcome is continuous. The second one is that we have 2 or more independent groups, and we do have different groups in this case because you can only have one of those answers to arthritis. You can't belong in more than one group. The third assumption is that we have independence of observations, which is really a design question as to how well the experiment was designed with regard to participant selection. And so we're just going to assume that that is okay because we haven't designed the experiment, and it's possible there were some problems with this because I believe it was a convenience sample. I don't know if it was through residence facilities or how that was done, but for the purposes of this exercise we will assume that that assumption is okay. And then the last 3, if you've got that layered page open, no extreme outliers, approximately normal, and equality of variances or homogeneity of variances. So let's have a look at the outliers. So I've got the box plot dragged in here. We're interested in strength, so that will go on the y-axis because we're looking at the box plots up and down. And then we would like to see a separate box plot for each level of arthritis because that's our grouping variable. So we'll put that in the x-axis and press OK. SPSS is thinking. So while it's thinking, I might just walk out the way a little bit. Are you going to do it? I don't know what's happening. Let me do it again. That was very odd. It took ages, but now it's done it twice now because I went through it twice. So let's have a look at this box plot, and I'll grab my little pointer. So we've got some outliers, and the question is, what effect is this going to have on the mean, and how is this going to affect our analysis? Now, if we look at these two outliers here, they're not too extreme. They're not that far from the rest of the data, and so I probably wouldn't be too concerned about them. Got another one down here. Again, it's a circle, not a star, so it's not quite as extreme. And we've got this one here, which is starting to get a little bit concerning. It's possible that these two would actually balance each other out a little bit. But the one that I'm actually worried about is this one here, because this person seems to be stronger than everybody else in the study, and they are definitely an outlier for this group here with the severe arthritis. So I sometimes get told that what people like to do is just delete any extreme outliers, which is not really best practice, because this could be a genuine observation. So it doesn't mean that it's wrong just because it's extreme. It's possible that this person actually was very, very strong. Perhaps he had a manual trade where he worked a lot with his hands, like maybe a fitter and turner or a mechanic. Anything that he used his hands a lot, he may actually have a huge amount of strength in there compared to the rest of the people in the study. However, what you can do if you want to is you can temporarily exclude them to see what effect it is having on the analysis, i.e. run the analysis with that person and without that person to see what difference it's making. But then in your discussion, you would need to include some mention of this outlier and whether or not this required some follow-up to see whether or not you were truly getting a good representative sample of all the people that you were interested in. In this case, they had quite a small sample, so it's possible he is representative. They're just missing sort of representation from all the people in between. And if he's not representative of the people that they are interested in, then if you were doing this as a study, you would be more careful with your participant selection. So in terms of the assumptions for ANOVA, this is a concern because he will have a big effect on the mean for this group here. He's going to pull that up quite a bit. So that's a concern. Let's move on to the next assumption about the distribution of the outcome being approximately normal for each of these groups. So I'll come back in here, and this is the one that we do in the legacy dialogues: histogram, hand strength, display normal curve, and we're interested in arthritis. Okay. Oh, and it did this one faster. Good. So let me grab my pointer again. So we can see those were the two small outliers from above, from the not at all group. That was our other outlier, and this was our really extreme outlier. In terms of normality, it's actually really hard to judge. The bigger problem is that there isn't a big enough sample in each of these groups. So it's worth pointing out that arthritis was not a focus of the study. The study was not designed to look at arthritis, and that's one of the problems in analysing data for something that it was never intended to be analysed for, in that you may not have a very good design regarding that question. So if this data was given to me and I was asked to analyse it, I probably wouldn't go ahead and use ANOVA, because we do have problems with the outliers. We can't tell if it's normal because the sample sizes are so small, and I just don't think the results would be reliable. So I would probably do a non-parametric test in this case, which we're not covering in this course. But I will very quickly show you how to run the test and do that last little test for equality of variances. So although in the sort of the bulk of the data it looks like there's less variation, because we've got this outlier here, the variation will look bigger for this one. And also we've got such small sample sizes, I don't think we're probably representing all the true amount of variation in the people we're interested in anyway. But let's have a look at just how we would run the test. And then in the next exercise, we'll look at a slightly different data set where it is more appropriate to run the test. So let me run that. Analyse, compare means. So these are the ones we looked at last week, one sample with paired samples, and then the independent samples t-test. I think the one and the paired should go together and have independent separately. One-way ANOVA. So you can do two-way ANOVA, and then if you want more than, so the one-way refers to the one explanatory variable, the arthritis. Two-way ANOVA, you might have two explanatory variables. You often use that in really well-controlled experiments. controlling for more variables, we'd probably do a general linear model. And I would actually do that probably just with 2 variables as well. So that's what the one-way refers to, because you might see a 2-way ANOVA as well. So we'll click on that. Dependent variable is the outcome, which is our strength. The factor is our groups, which is arthritis. And let's have a quick look at the test of variances here, Levine's test. Okay. Ah, that's interesting. So this output is actually a little bit different to the previous version of SPSS, and I didn't realize that before. It's given us a few tests. So what I would advise you do, just to be consistent with both versions, I believe in the other version it'll just be the one test based on the mean. So what we're going to do is just look at the top row. So the null hypothesis is that there is no difference in the variation, and we've got no evidence against that. It's quite a high p-value. So we will accept that the variances are equal. And then for the ANOVA, the null hypothesis is that there is no difference in the average hand grip strength between the groups. Very high p-value again, so we've got no evidence against that. So we would have to assume, so we haven't disproven the hypothesis. I don't think this evidence would be strong enough to go ahead and say, yes, hand grip strength is the same no matter what your level of arthritis. But so far we haven't found any evidence against that. So I'll leave that video there, and then in the next video we'll look at another example with data that illustrates some different properties, and then we'll go on to also do the multiple comparisons. I do like to look at what we might call badly behaved data just as an example, because it's possible that this is what you're going to see when you do research in real life with your project. So it's good to know what happens when things go wrong. And in this case, things really have gone quite wrong, and I would actually go on to use probably a non-parametric test, if anything, just because the sample sizes are so small. And so it's something to be aware of, that there is a point where we just don't run the test. Often when we look at introductory statistics, we go ahead and run the test anyway, even if the assumptions aren't met, just because we don't have any other tools to use in those situations. So if this happens for your projects, probably a good idea to send me a couple of graphs, let me take a look, and we'll make a plan of what we're going to do with it. One possibility here is that you could combine groups, that you look at people who have no arthritis versus people who have any level of arthritis, and then combining those 3 groups, maybe you would have enough of a sample size to make some kind of comparison.